Alright, so in this video, I'm going to be solving the problem 9 to the power of 10 plus 9 to the power of 10 plus 9 to the power of 10. And for this problem, I actually have 4 option choices. So for A, I have 27 to the power of 30. For B, I have 9 to the power of 30. For C, I have 27 to the power of 10. And for D, I have 3 to the power of 21. So to first start out, let's go through all these option choices and see if they're right or not. So we first have A, 27 to the power of 30, and how this likely was resulted in was from adding all the bases and adding all the exponents. So we have 9 plus 9 plus 9 to the power of 10 plus 10 plus 10, which is equal to 27 to the power of 30. And this is actually wrong because this is not the proper way to add exponents. So now going from here, this was likely gotten, 9 to the power of 30, by keeping the base the same and then adding the exponents. And this again is wrong because this is not the right way to add exponents. Now we have 27 to the power of 10, and this was gotten from adding the bases, but keeping the exponent the same. And this, again, is wrong as well. That's not how you add exponents. Now, 3 to the power of 21, which is by process of elimination the right answer, we're going to see how they got this. So we first start with 9 to the power of 10 plus 9 to the power of 10 plus 9 to the power of 10. And I'm going to factor out 9 to the power of 10. So I get 9 to the power of 10 times 1 plus 1 plus 1, which is equal to 9 to the power of 10 times 3. And now this is equal to 3 squared to the power of 10 times 3. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 2 to the power of 10 is going to equal 3 to the power of 20. And I have this times 3 to the power of 1. So I simply just add the exponents. This is equal to 3 to the power of 21. Now, if you haven't already, please make sure to subscribe, leave a like, and share this to any of your friends or family members. Alright, so in this video, I'm going to be proving to you guys that 2 plus 2 is equal to 5. So, to do this proof, what I'm first going to do is start with a true statement, that 0 is equal to 0, which is obviously a true statement because any number is equal to itself. Now from here, what I'm going to do is rewrite 0 on my left-hand side as 20 minus 20, and rewrite the 0 on my right-hand side as 25 minus 25. So now I get 20 minus 20 is equal to 25 minus 25, which is again a true statement because 20 minus 20 is 0, and 25 minus 25 is also 0. Now from here, I'm going to rewrite 20 as 4 times 5. So now I get 4 times 5 minus 4 times 5 is equal to 25. I'm going to rewrite this as 5 times 5. So I get 4 times 5 minus 4 times 5 is equal to 5 times 5 minus 5 times 5. And now, if I have something in the form a times b minus a times b is equal to b times b minus b times b, which is this form, well, notice how we can simplify this by factoring out the greatest common factor. So for my left-hand side, we have a greatest common factor of either a or b because both of them are in both terms. So what I'm going to do is I'm going to rewrite this as a times b minus b. Basically, I factored out a. Now for my right-hand side, all we have is b because that's the only term for my right-hand side. So I'll just factor out b. So I get b times b minus b. So now in the case of this, for my left-hand side, I'm going to factor out 4. So I get 4 times 5 minus 5, which is equal to, for my right-hand side, I'm going to factor out 5. So I get 5 times 5 minus 5. So now I have 4 times 5 minus 5 is equal to 5 times 5 minus 5. And what we can do over here is, if I have something in the form a times b minus b is equal to b times b minus b, we'll notice how we can just cancel these two out, meaning that a is equal to b. So in this case, I have 4 times 5 minus 5 is equal to 5 times 5 minus 5. I can divide both sides by 5 minus 5. And these two cancel out, these two cancel out, and I am left with 4 is equal to 5. Now, going back to our original equation, I said that I was going to prove that 2 plus 2 is equal to 5, right? Well, what is 4 equal to? 4 is equal to 2 plus 2. So I get 2 plus 2 is equal to 5. So I just proved that 2 plus 2 is equal to 5. And now I know what you're thinking. This is mathematically incorrect, right? How can 2 plus 2 equals 5 when 2 plus 2 is equal to 4? Well, look back here and try to figure out where I made an error. So the error is actually right here in this step where I divided both sides by 5 minus 5. So let me write this right here. I have 4 times 5 minus 5 is equal to 5 times 5 minus 5, right? Well, instead of just going on and dividing both sides by 5 minus 5, what is 5 minus 5? 5 minus 5 is equal to 0, right? So this is basically 4 times 0 is equal to 5 times 0. And then now, if I try to divide both sides by 0, well, 0 divided by 0, that is not equal to 1. 0 divided by 0, that's indeterminate. So we can't actually cancel these out, because if we cancel it out, we're implying that 0 divided by 0 is equal to 1, which is wrong. So that's actually where I made the mistake when I canceled out the 5 minus 5s. I wasn't allowed to do that because that's basically dividing 0 by 0, and that is against the laws of mathematics. So this means that 2 plus 2 is not equal to 5. So, yeah.